Welcome to the lair of the Batty Boffin.
Hi there Batty fans, welcome to another Batty Boffin video all about electricity. Now in earlier videos I introduced you to the concepts of voltage, current and resistance. Voltage being the amount of pushing force that the battery is using to push the electricity around the circuit. Current, that's the amount of electricity flowing past any point at a time. And resistance, that's these things like resistors or motors or lights, the components that are kind of resisting the flow of electricity and using it up. So, firstly, a little bit of revision for you. I'd like you please to write down what the units are for voltage, for current and for resistance. And if you can remember the units, the little symbols that we use for those as well, that'd be great. Okay, you can pause the video and do that now, please. We should have these. Voltage is measured in volts. That's a nice easy one. And the symbol for abbreviating that is just a V. Current is measured in amps. And you can have things like milliamps for little tiny amounts of current. And the abbreviation for that is A. And resistance is measured in ohms, named after a guy, so it's a bit of a funny spelling. O-H-M-S. Ohms, and the symbol for that is that omega or omega shape, which I always think looks like a little kind of smiley face with big shoulders on it. So those are the units we use, and we measure them with devices called voltmeters and ammeters. And I think I showed you those little handheld Avo multimeters you can get, which measure them yourself, quite easy to do. So here's our basic circuit diagram with our ammeter done in series and our voltmeter wired in parallel. Now that's okay, but it's a little bit boring. We could put some slightly more interesting things in, and we can do some circuits that you can actually build at home. You're just going to use things like AA batteries up there. Never ever mess with household electricity. Don't use the stuff that comes out of the wall sockets. Always batteries, much safer. So we've got some extra symbols you can add into your circuit diagrams. This first one here is a switch, and that's shown in the open position. You know, you could fold that down and shut the switch so the electricity would flow. So at the moment, that's an open switch, which means no electricity is going to flow. It's an off, if you like. And then these two symbols are both symbols for the same things, and that's a filament lamp, just an ordinary light bulb. Again, we're not going to use these big ones that you actually use in your house. You get little itty bitty ones you can just get from some kind of hobby store, things like that. They're quite easy to get hold of. And they run on things like 1.5 volts or things like that instead of the big ones in your house. So those symbols both are the same thing. I'm probably going to use that one, I think, because it looks like a piece of wire. And you know, in filament bulbs you can sometimes see the little ring of wire, and that's what that's supposed to represent. So here's time for you to do something. What I'd like you to do is pause the video, draw yourself a circuit diagram. You don't need to have the resistance in it this time. Put a light bulb in instead and have a switch. So draw yourself up a circuit diagram and pop back in a minute and we'll see what I've got as well. Hi there. So you should have a diagram that looks something like this perhaps. It doesn't have to be arranged exactly the same as mine, but we need to have this battery or cell here. You tend to use the word cell if it's just one, battery if it's a whole load put together. It doesn't actually make a lot of difference. And you can either show it with one short long or several short longs like I've got here. So here's my battery of cells, and this is the switch, which is currently open, which means no electricity is flowing. Round here I've then got a light bulb. You could use the other symbol if you like, and then it joins back onto the battery. Now this is actually something you make very easily yourself. I happen to have this handy dandy little clip circuit kit, but you can just use an ordinary battery and some pieces of wire which you can like stick on with sellotape or hold on with pegs or something like that. I've got a switch here, and we can see it's got the right symbol. That's my switch symbol there. And this here is just a little mini light bulb. So fabulously, when I close my switch, ta-da! It's amazing, isn't it? So that's my basic circuit, and if you want to have a go with doing some of these, you can. Other things you might like to investigate are maybe putting an extra light bulb in, because what we can do, we don't have to have just one light bulb. I'm actually going to put another one in here. So something for you to have a think about. When I put another light bulb in my circuit, I'm going to put one just here, what do you think's going to happen? I've got the same amount of electricity being pushed around. These batteries are doing the same. Okay, so that's pushing out the same amount of electricity. But I've got two things, because these act as resistors. I've now got two resistors in my circuit. What do you think's going to happen? Pause the video and have a think about that. Welcome back. So here's my circuit, and I've now got two lights in it. So what will happen when I switch it on? Will one light, both light, neither light? What? Well, the answer is they both light up, but not very much. This one lights a bit more than this because this one takes more electricity. It's actually a higher resistance in there. So this one lights up and this one lights up, but not quite so much. It's like they're kind of sharing the electricity between them. And in fact, what I can do is measure the voltage over them here. We have 1.5 volts from this battery and 1.5 volts from this battery, and that voltage is being shared between these bulbs. So instead of this one having 3 volts all to itself, which it did originally, we've now got 1.5 volts there and 1.5 volts there. So here's a little video of me measuring the volts so that you can see that. So here's our circuit with two lights in it. When I switch it on, we see they both come on, but quite dimly. So we'll measure the voltage drop. Check out the needle here. Over this one, a little under 2, about 1.5 volts. There we go. And for this one, again, the same. A little under 2, about 1.5 volts being taken by each lamp. Whereas here's what happens when we have just the one bulb in. So we're going to measure the voltage over here, and you'll see that the whole 3 volts is being given to this one light. Here's the video again. In this circuit, we have just one light on here. And if we measure the voltage drop, which you can see on here, goes from 0 to 10 at this side. If I measure the voltage drop over the light, we can see it flips up to between the 2 and the 4. So that's 3 volts being provided by these two 1.5 volt batteries. So that's 3 volts coming through and lighting up this light with 3 volts. Compare that to when we have 2 lights in the system. So that's what's happening with the electricity. It's being shared between the lights. Sometimes one bulb has it all to itself, or if you have 2 bulbs, they have to share it. So you could have a quick experiment with this, either with a set like this if you've got one, or just some pieces of wire, little croc clips and some little mini bulbs that you can pick up from a hobby shop. So have fun with that, and I'll see you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!